I did make sure to include the homework again. It's the same homework questions that were posted last week. It's the same homework questions that are on Canvas right now. I don't think they were in the lecture slides. So now in the most recent post, this actually showed up in the lecture slides. Okay, so nothing's changed, but some people like to see the numbers again just to make sure. So we didn't write them down, we got them as well. Significant digits. So this is becoming, particularly if you were here in the morning, I'm going to try and negotiate away from some of the issues with this. But significant digits are something that are going to haunt you throughout this entire semester. Okay? Very least for the first test, you're going to have multiple choice answers that all match what your calculator spits out, but you have to be able to add that extra interpretation factor with your significant digits. Okay? So applying those carefully. So realize you need to be able to identify how many sig figs are in each number that you work with, and then how to manipulate those, which is when you're doing your addition, subtraction, multiplication, division, and then also evaluate rounding. Okay? So you have to have these, for lack of a better word, memorized as far as how you would apply them. Okay? So make sure you've got these nailed down, because it's going to show up on the test. Okay? If we start shifting to really big or really small numbers, that's where we bring in our Greek prefixes. Based on this morning's class, there are still people that don't have these memorized. Your test is next week. If you don't have the ones in red that are memorized yet, you need to get those nailed down. You have to be able to apply those. Okay? Everything else you are still officially responsible for, you just won't be tested as heavily on. The ones in red you absolutely must know, like I said, to pass the class. Okay, so you're going to see a decent amount of points associated with those. The next thing I noticed is that people are having some hard times interpreting what these things mean. Okay, so if we stick with the tera, that capital T symbol means 10 to the 12th. But let's say I wanted terameters. Okay, what does that mean? Well, a terameter, 1 terameter is 10 to the 12th meters. So when we're looking at these and how they apply, those prefixes are your adjustment on the standard unit or our base unit. So if you want to know how many meters are in 1 megameter, it's 10 to the 6th meters. Okay, so that's what this table is trying to tell you. These numbers apply to the base unit. Meters, grams, liters, seconds. Okay? So if I wanted to convert to centimeters, 1 centimeter is 10 to the negative 10th, 10 to the negative 2nd meters. Okay? So that's what those scientific notations, your multiple or fraction, are applying to. They always apply back to the base unit. Where this can be confusing is if you've memorized centimeters as something else. Okay? What happens, or what's another way to convert centimeters to meters? Back and forth. Anybody? Anybody heard 100 centimeters is 1 meter? Okay. You might have heard or seen that. If you're one of those people that has or is comfortable with that notation, 100 centimeters is 1 meter, and you've been having some problems interpreting this, you should talk to me after class. If that 100 centimeters is 1 meter thing rings no bells, use everything that's on here. Those scientific notations always apply to the base unit. You don't have any problems. Okay. Where I think a lot of that confusion is coming from is the alternate orientation of the scientific notation. Okay, or an alternate interpretation. Any questions with that? No, it's kind of vague and open-ended. If you apply, when you do your conversions, your 10 to the power always applies to the base unit. Meters, grams, liters. Okay, every single conversion, it will work, I promise. Okay. Unfortunately, actually before we do that, if we take a look at these conversions, so let's pick one of these. Since we said centimeters, let's do that. If we take 1 centimeter, that equals 10 to the negative second meters. If we were going to rearrange that, we could divide either by our 10 to the second meters or our 1 centimeter, and we could get our unit fraction. Okay, or as I like to call it, a conversion factor. So 1 centimeter is 10 to the negative second meters. If we were going to put this into an equation, okay, try and convert meters into centimeters, we would need to know how many sig figs this conversion factor brings in. Okay, how many sig figs do we get? What's that?
It's infinite.
Okay, this comes back to some careful observations that we're making with this. Okay, the common response might be 1 sig fig, or the 1 in the 10 number. Okay, however, that's assuming it's a measurement. Okay, when we're converting between centimeters and meters, it's not a measurement. It's defined as the number of meters in centimeters, or the number of centimeters in meters, which means the sig figs happen to be infinite. It's an exact conversion. So when we're going to convert between meters and or any metric system within these prefix units, all of those are exact, which means your sig figs are infinite, which also means you don't have to worry about those conversion factors affecting your answer as far as the sig figs go. You'd have to be given some other number to convert, and that's going to be the one that identifies it. Okay? So conversions within the metric system, exact. What happens when we have to convert? Actually, before we even do that, let's assume we're in the English system. Let's do feet to inches, or inches to feet. Let's do inches to feet. Okay, what's our conversion there? How many inches are in a foot? We get 12 inches equals 1 foot. If we change that into our conversion factor, we could say 12 inches per 1 foot. How many sig figs are in that conversion factor? Okay. We're running back to the same issue that we had before. Evaluate this. Is this a measurement? Okay. Is there 12.1 inches in a foot? No. How many inches are in a foot? 12. How many? Exactly 12. Which means how many sig figs within the English conversions?
Infinite.
Infinite. Okay, so if we're going to convert different measurements, as long as we're within an individual unit system, those are exact conversions, which is kind of nice, which means those sig figs don't matter to us, okay, because they're all infinite. What happens if we transfer between systems, though? If we try and convert English into metric, or metric into English, in that case, we're no longer exact. Those carry sig figs with them, okay, which is kind of an unfortunate thing. There are ways that we can kind of negate that conversion factor, or negate that conversion issue. The way we do that is we know what the conversion factors are, and we make sure that we supply enough digits in our conversion factor that it is effectively infinite. It's not going to control the answer. Does that kind of make sense? So when we look at 1 inch being 2.54 centimeters, ooh, that's a bad one. Why is that a bad one?
That's exact.
According to our footnote, that one is exact. Exactly 1 inch is exactly 2.54 centimeters. So let's pick one that's not exact. Let's do the 1 pound is 454 grams. So 1 pound equals 454 grams. Again, if we converted this into our conversion factor, we could say 1 pound is 454 grams. How many sig figs? All right, this one gets a bit trickier now. According to that number as it's written out, what would we assume our sig fig count was? 1 because of the 1 pound. Okay? However, careful with your footnote. What's the footnote say? Assume 3. So this isn't really 1 pound is 454 grams. Really what we're doing is being lazy, and it's actually 1.00 pounds is 454 grams. Okay? So when we're looking at between different systems, different measuring systems, metric to English or English to metric, we can assume 3 sig figs. Okay? Does that kind of make sense? We'll use that whenever we try and go through and do our calculations with future problems, which we'll see in a second. Okay? So we did the conversion of length in centimeters, and that calculation, what we found last week, was we only could use 2 sig figs. All of our conversions are either infinite or 3 sig figs, but what we start with was 120. And in the number 120 yards, only the 1 and the 2 are significant. The 0 is not significant because there's no decimal place. As soon as we bring in that decimal place, then we can evaluate that 0 being a significant digit. Until then, it acts as a placeholder, and it has no other meaning. Okay? And yeah, we will look at several examples with this in just a second. Any questions on that, or you guys want to see any examples? Okay, so let's push to some examples of working with this. We can go back to our compound units. What are the units for a speed of your car, bike, or a walk? Okay, we usually get a distance, and since we're in America, we use miles as our unit. Okay, primarily because that's just roughly how fast we end up traveling. If our standard travel speed was something along these lines, we probably wouldn't look at it as miles per hour, because what would our number be? Really big or really small? Really, really small. So we would adjust our either distant or time unit to give us a more manageable number. Okay? So what's an average speed? Let's see if you guys are any better. I mean, 45. I like that number a lot better than last week. A lot more reasonable. 45 miles per hour, we might write it out as. Okay, the other way to write this out, you might see people writing it out as 45 miles per hour, which is a little bit better. I would actually recommend that we push it to the extreme. It is 45 miles in how many hours? 1. So there's an implied 1 there. The reason I do that is I can now see that complete conversion factor. I can see all of the numbers that affect those calculations. Okay? Why draw it out like this? Well, if I now want to convert into something else. Okay, let's say I want to know, let's pick a good question here. Let's make sure I can do it with bad sig figs first. How many or how far did you travel in, let's make it a little, well, let's go simple first. Let's say 2 hours. So the first thing we're going to do is leave it at that. Okay. To solve, what do we need to bring in first? As we talked about last week, where do we start with our solve? We want to address our answer first. Get some information down there. Feel positive about what you're doing. So let's bring in our equal sign and our answer. What do we know about our answer? It's a distance, because it's how far did we travel. But what measure of distance? Does the question say miles?
No.
No. What's wrong with the question? It is way too vague for you to provide an answer. So what should you do as a student? There's 2 possibilities. Okay, if you skip it, you'll potentially lose points.
You assign a value to the units.
Raise your hand and be like, yo, there's something wrong with this test. What units do you want it in? Okay, or 2, say I'm going to be a sneaky jerk. I'm going to pick whatever units that I want that are the easiest for me to solve in. And if they wanted me to convert to some other unit system, they didn't write the question appropriately. When they come back and tell me I'm wrong, I'll write it back around and shove it in their face and say, hey, you didn't tell me what units to put it in. Tell me this unit is wrong. And the answer they're going to give you is, you're right, and give you the points back. That said, I know that, so I'll try and write the questions better. and we would change it to, let's say, in miles. So what do we know about our answer now? Now we know our units end up being miles. Where do we go now? So there's a couple places we could start. Both of them are equally valid. Where do you want to start it?
You need to, hours and minutes are two different values.
True. Do we have minutes? At least yet.
So you need to get those the same.
Do we have minutes yet?
Well, we do, because, it's 45
It's
miles
still
per
hours.
hour. Oh,
Yeah.
yes, okay.
Okay, so we don't have to worry about the minutes yet. Okay. Most people will start the problem off with the information that's given, and the information that we're going to say is given is almost always the thing that's just in the numerator. 2 hours. Okay, why start with that? It looks pretty. That's about it. Okay. It's not our conversion factor. So when they set up a standard problem, we almost always start with something that's not a conversion, then do the conversion factor to get to our converted answer. Okay? There's no reason behind that order. It's completely arbitrary. Up to you and to decide how you want to organize it. So we can start with what we're given. We're given 2 hours. We need to somehow convert time into distance. To be able to do that, we have to have some conversion. So what we would do, bring in our conversion factor, multiply by something. Okay? We'll compare what we've got to what we end with. Where are the miles in our answer? Numerator, denominator. Or we can try top versus bottom. It's in the top, which is the numerator. I always get it backwards too. Really? You're going to laugh at me for that? So cold. So we need miles on top. We take a look at what we start with. We start with hours in our numerator. Our hours in our numerator for our product. Let's take a look at, our answer. Take a look at the answer. Does hour show up as a unit? It says equal miles over 1. Anybody see an H in there? Or an R? No. Which means we have to somehow get rid of this hour unit. What's the easiest way to get rid of it? It needs to be in the denominator. So we can put in our hour unit underneath. So now we approach, do we have a relationship between these two? Now we can go back and either look at all our conversion factors, or in this case, what our problem would also tell us, 45 miles in 1 hour. When we track, what happens? Our hours as units cancel. And what are we left with? Miles. We've now answered our question as far as our units go. For longer problems, what you will see me do, at least when I try and solve them out, I'll probably do it all in a calculator, however. What I would go through and do is, now that my units are good, I would take the numerator and multiply everything in the numerator out. So 2 times 45, we get 90. And then I multiply everything in the denominator out. 1 times 1 is 1. Why did I not bring units through on this case? Because I already did it. I don't have to worry about bringing units across. Setting up the problem dealt with my units. Once my units are sorted out, now I can go back and deal with the numbers. Now I can punch in 90 over 1 into the calculator, which means 90 divided by 1, and we get as an answer 90. Okay? And we would write down for our answer, or what we would get out of our calculator, is 90 miles. Before we start to evaluate whether or not that's a valid answer, or bubble in answers, what do we need to make sure of? Sig figs. So we'd have to go back through with our conversions and make sure that our sig figs come out okay. So, go back through the problem. In our 45 miles per hour, how many sig figs?
2.
Okay, why do you say 2? And I agree. All right, and this is a tricky aspect of it. That speed is a measured value. Okay, it's not a direct conversion. This is something that we measured, which means, whoops, sorry. It's measured, which means we have to evaluate the sig figs in each case. So 45 gives us 2 sig figs. What about the 1 hour? So that means sig figs should be 1. Okay? Because those were measured values. Okay? When it comes to the problem, or when it comes to your exam, I'll make sure that your units are very, very carefully, and the numbers used are very, very careful as far as the amount of sig figs shown. Okay? As this is written, we're looking at 1 sig fig in this because of that hour. Yes?
Okay, this is the main problem I have with sig figs.
Yes.
That if you change that sig fig to 1, it totally changes the value. You go from 90 to 9.
No. Be careful with that. It does not. And we'll look at 2 reasons why not in a second here. Okay? So that's our first evaluation as far as sig figs. We now move to the next one. How many sig figs do we get here? 1. So even if we'd said our conversion had 2, we'd still end up with 1 sig fig in our answer. We'll just do SF for sig figs. When we go to our answer, we now need to evaluate how many sig figs are in that number written as is, 90.
1.
There is only 1 significant digit. What is that 0 doing? It is a placeholder saying that that's not the number 9, but the number 90. It's shifting the 9 from the 1's place into our 10's place. So the 0 will always carry some kind of meaning. It's always there for a reason. What that meaning is entirely a separate question.
Oh, so if, I'm sorry.
Oh, yep.
So if it was 91, it would obviously be 2 significant figures. So you would have,
let's adjust our speed. Do I think I can do this?
46.
Let's just make it 46. Okay. We make it 46. I don't know why I'm converting it all the way up there. Let's make this 46. 46 times 2 is going to give us, thank you. Honestly, thank you. I wasn't trying to be sarcastic. 92. Now when we look at our answer says we have 2 significant digits, both the 9 and the 2. Go back to our calculation. We still have to go through and evaluate what happened in each of our other cases. Our conversion factor is 1 sig fig. Our starting thing has 1 sig fig, which means our answer needs to have 1 sig fig. So what we can go through and do, and this is something I've started picking up as a habit, is marking the sig fig by underlining it. That number is significant. This next one is my first insignificant number. So what I will do is write down my 9, and then I've got to decide, first off, its place, which we'll see in a second here, is that this 2, what's its relationship to 5? Less than, greater than? Less than, what does that mean as far as rounding?
Round down.
Okay, we'll leave this as a 9. We still have to force that 9 to be in the 10's place. To do that, what do we put after? We'll put in the 0 as our placeholder.
So if that was if the 2 was a 6, then you round up to 10. And so it's all about rounding.
Yes.
Okay.
Okay. How else can we clarify this to make sure that we only hit 1 sig fig? If we're careful, if we bring in a decimal place, how many sig figs do we have? 2. So it's not just bringing in a decimal place. There's one more important aspect to it. Convert it into scientific notation. Now in scientific notation, I have only 1 significant digit. And in this case, I don't even need that decimal point. Okay. So our 10 is the replacement for that 0 placeholder. Okay, so when we convert into scientific notation, the reason, or one of the reasons we do that, is to account for those placeholder zeros that we didn't want to include in our number. Okay? And since I just wrote a bunch of numbers without units, which I'm going to guess is why you were smiling at me. Go ahead and drop those in too. Okay? Questions about that? Okay. Then let's make it more challenging. Let's try another one. In this case, I'm going to ask time. Okay, how far away does someone live? Yeah, how far away do you live?
20 miles.
It's got to be in units of meters, though.
20 kilometers.
Let's just make up a number. So let's do 20 kilometers. Okay. How long? Now we got to be careful here. Long is looking at time to answer our question. Make sure we're specifying correct units. So let's make it particularly obnoxious. How long in seconds? Ooh, why is that going to be problematic? We're going to have to convert our hours over into seconds. How long in seconds does it take to travel? Let's do, we said 20 kilometers.
Yeah, you could play with that.
I'm trying to decide how I want to do it. Let's go ahead and do it this way. 20.0, and I'm going to make some adjustments here. We'll call this 1.0, yeah, 1.0 hours. Oops, 20 kilometers, right? Okay, so we'll have several aspects to this problem. Number one, we actually have to solve for our units to get it correct. Then we have the math. Then we have the sig figs. We have to apply each of these things stepwise as we approach the problem. Okay, so where do we start our problem, being the optimists that we are? Equals, what do we know about our answer? It needs to be in answers of seconds. Okay? You got to make sure that you're identifying what you're trying to solve for. Okay? Long in seconds. Now what can we do?
We're going the same speed.
Yes, we'll assume we're going to do on that same speed. What was that?
20 kilometers.
We can start with, and this is where most people will get a little bit slow, or not slow, lazy. What should we write here? We need all those zeros. Why do those zeros, or why are those zeros important? We're going to need those when we go through to calculate our sig figs later on. Remember, I like to put the over 1. It's up to you. You don't have to do that. Okay? So our next approach, as we've been doing with all the simple problems, is we need to somehow get kilometers to equal seconds. So we evaluate, okay, our kilometers in our answer. So what's our answer? Seconds. Do kilometers show up in seconds? No. So somehow or another, I have to multiply by a conversion factor that gets rid of kilometers. Okay. I also want seconds showing up in the numerator. And right now, seconds do not show up in the numerator. So we'll get there. I know. We'll put in seconds. Okay. Do I have a conversion between kilometers and seconds? No. Okay. So that kind of stinks. We don't have a correct approach to this. Okay. Or we don't have something that's going to work. So what we're now going to have to go back through and do is see, do I have something that can relate to either of these? Okay. The only other piece of information we've got is that we went 46 miles in 1 hour. Okay. Do you know a relationship between, or so first off, what do miles measure? Distance or a length. What do kilometers measure? Distance. So our kilometers are tied to miles. There's got to be some relationship between those. What do seconds measure?
Time.
What do hours measure?
Time.
Time. So what we're going to do is try and find a relationship between each of those units independent of each other and hope in the process of going through this that we can get our units to cancel out. Which do you want to look at first? Time or distance?
Distance.
Okay, pretty unanimous on that. Okay? So we want to somehow set this up where our kilometers can be converted into miles because we have some information about miles. Okay? What is that relationship? Anybody remember it? Anybody have it? It's 1.61, but I don't remember which way it goes. Which one's longer? Miles or? No, kilometers are shorter, right? So it should be 1.61 kilometers and 1 mile. A 5K is 3 miles. Did I do that right? How would I expect you to do this on the exam?
You provide the unit.
I'm going to give you that conversion. How would I give you that conversion? Let's go ahead and draw it in black here up at the top. What you would see is 1.61, yes, kilometers equals 1 mile. I would expect you to take that information and turn it into the unit factor or conversion factor. Okay? So cool. This is kind of nice. We got rid of our kilometer issue. So those units cancel out. But at the same time, we've now introduced a new issue. We now have miles, and I wanted seconds. Okay? So just like we did with the last one, we're going to go through and do the same kind of idea. Do I have a conversion factor between miles and seconds? No. So what we'll do is, again, step back and see if I have a different relationship. Miles was a measure of distance. Seconds is a measure of time. Do I have a conversion factor between distance and time? Yeah. Miles per hour. Okay? So it may not be the correct time yet, but I do have that relationship. So we'll go through and do that conversion. Miles, hour. Where do I put numbers? It's the number in front of the hours. 1, technically 0.0. And the number in front of the miles? 45 miles. Go through and evaluate again. What happens with our units? Our miles cancel. We now have a unit of time equal to a unit of time. Pretty good, except they aren't the right units. They aren't the same units. Can I convert? So now we'll go try again. Is there a conversion factor between hours and seconds? Those of you that are good with that math, don't do that. Do we have a direct conversion there? Okay. Most people don't have that memorized, so we don't have that. Do we have something else that we can relate between those two? We've got minutes. What's the relationship between minutes and hours? 60 minutes is 1 hour. Ooh, wow, look at that. Would have thought I planned it. Minutes to seconds, do I have that conversion? 60 seconds is 1 minute. Track the units, what happens? Our minutes cancel, our hours cancel. What we've now done is set up our problem to give us our correct units. Now we can go through and solve the math. Okay? Again, how would I go through and set up the math? I would take the entire numerator. That says numerator. Just trust me on it. And denominate, yeah, I'm going to do the same thing. We've got our denominator underneath. So I would go through and take 20 times 1, which equals 20. So we can simplify that. Times 1, 20. So what I would punch into the calculator is 20 times 60 times 60. I would then go through and do the denominator. 1 times 1.61. 1.61 times 45 times 1 times 1. Again, I won't worry about those. 20 times 60 times 60. How did everybody come up with different numbers on that?
You went all the way with it.
70, you said 7,200?
72,000.
1,000? Divided by?
72.45.
Really? 7,245?
There should be 72,000, you have 7,200.
72.45.
Or 30, no, that's right, 7,200, okay.
72,000? over 72.45. Wow. I completely guessed at numbers and I got 272s. That's pretty impressive. Now that I've done all the multiplication, now I'll go back and I'll do the division. 72,000 divided by 72.45. Okay. The reason I format it this way is I don't worry about the multiplication division issues. Particularly if you switch up the order of operations, make a mistake in entering it into your calculator, you can very well accidentally end up swapping which one was in the numerator and which one's in the denominator. This way it solves it automatically. You've already got it organized. What do we get as an answer?
99.4.
No more sig figs? Is that all you're going to give me?
Well, there's 99.37888.
378.
82.
82. Your calculator spits this out. Guaranteed, probably going to be an answer. Is that going to be the right answer? Uh-oh.
I got 990.
Yeah, that's what I got.
So watch for the zeros. Okay. Would that be the correct answer now? No, what's wrong with it? Sig figs. So we now have to evaluate our sig figs. So we'd go back through our calculation and try and determine what our sig fig count was. This will be fun because I'm running out of space here, so I'm going to erase the question. Is that okay with everybody? Can I erase the question on that? And we'll do our sig figs written over the top of everything. Okay? So we can go through and evaluate each thing. Our first, or I guess last. How many sig figs in that conversion? 60 seconds to 1 minute. It's infinite because it's within that unit system, within our time scale. We're looking at infinite. There are exactly 60 seconds in 1 minute. What about the next one? Same, infinite. Next one. 2 sig figs. Next one. Why 3? That 1 looks like 1 to me. With changing between English and metric systems, we assume 3 sig figs. So even though we didn't specify the extra zeros in that conversion, it is implied from our table. Our English to metric, miles to kilometers, is implied at 3 sig figs. Okay, so even though we haven't shown the extra zeros on that 1, they are implied. If it helps with you, add the extra zeros whenever you have to switch between those 2 units. Okay. Our start. Why is it 3? Our decimal place allows both zeros to count. So we now go through and evaluate. In our first, or as we run our calculations, where's our sig fig answer going to fall? At position 2. We can only carry 2 significant digits through our answer, which means we go to our final answer, and again, the same idea. Underline the significant digits. It's the first and our second. The rest of those are non-significant. We'll look at rounding. 3. Is that less than or equal to, less than or greater than 5? Less than, which means our final answer, 990 seconds. Okay. Awful lot of work to go through and do one problem, but that's the way it works. Okay. Questions about that? So you notice we write out our problem, start with where we want to end, then start with what we're given, and slowly start plugging away at conversion factors until we can get it across.
Why are we only allowed 2 sig figs? Why don't we do 3 or infinite?
When we're doing multiplication and division, what's our rule?
Least.
The least number of sig figs. I know you're sitting on front of the screen, that's difficult to see, so let me pull out the red pen here. Our least number of sig figs shows up right there in the middle as 2. That's our lowest number in our conversion between our miles and hours. Okay? Very irritating. Okay. Other questions on this? Any questions on this for that matter?
How do you write it? 920, 9 times 10 is 100.
So if we're going to now convert to scientific notation, I'm going to have to erase to get some more space up here at the top. We had 990, and if we want to convert that into sig figs, or sorry, not sig figs, scientific notation. First thing we'll do is put the decimal place after the first sig fig, followed by the rest of the sig figs. Is our 0 significant? No. We still want to hold only 2 sig figs. The next part is to identify our times 10 to the what. So times 10 to the, what we'll do is go back and evaluate how far we shifted. We have an implied decimal place right after the 0. 1, 2 places to the left, which means our number is going to be 2. What sign should that 2 be? Positive. We now have 9.9 times 10 to the second seconds. Oh, that was kind of fun. Okay. Whew. How are we doing? We'll get to that question a little bit. Critical thinking, yes, question.
The homework, and shame on me, but I haven't even touched it yet. But does the homework, is it going to give us a large enough quantity of these kind of problems to get us so that we're...
The homework should get you fairly confident with it to ultimately test yourself. You should do more.
Okay, so that leads me to my question. Is there more somewhere that we can find?
Yes, so at the back of the textbook, or the back of each chapter, I've only gone through and picked out a few of the odds in each individual section. You should be able to find at least one more odd question, and definitely tons more, twice as many even questions. Okay. I guess you did the math, huh? Critical thinking. If we evaluate our units, we need to be careful with what our units mean, so it ends up applying to what we're doing in the real world. If we take 100 square feet, what we're saying is we are taking, we are taking a foot, or a square that is a foot on each side, and we take 100 of those. If we measure 100 feet square, what we're saying is we take 100 feet times 100 feet. We'll get drastically different answers. Okay? So 100 square feet is a measure of area. 100 feet is a measure of distance. We then square that value to get our area. So very, very similar as far as what the units sound like, but they mean drastically different things. So be careful when you're looking at your units to make sure that you're interpreting them to mean exactly what they're supposed to mean. And it's not always obvious in some cases. Okay? Why are units even further important? NASA engineers, at least according to your textbook, which might as well believe them, said or started to do a bunch of different calculations when they're trying to put together the Mars climate orbiter. This is not the nice fancy one that landed nice and safely. This is the one that was supposed to go around Mars and just check it out. Okay? Kind of look from the skies. Somebody did a mix match on their units. Somebody measured everything in metric. Somebody measured it in English. They compared their numbers, and they probably said the numbers looked fine, but they didn't check the units. What was the problem? They had really different results. So someone looked at it and said, yeah, that looks approximately right, and let it pass. What happened? Well, instead of that Mars climate orbiter chilling out around the outside, it crashed into the surface of Mars. Very difficult to monitor the external climate if you're buried underneath it. Okay? All of that, yeah, and you probably end up getting fired. All of that comes back to units. Okay, so we go through and you may think that you're struggling with it and that's horrible and life is terrible. Realize there's someone probably getting paid millions of dollars to work on a multi-million-dollar project. They screwed it up. Okay? So it's a very easy concept to mess up and make simple mistakes on. The idea is that you practice enough in class that by the time it becomes important, at least as far as your class is concerned, the exams, you're confident enough with it, with how you set your problems up, that you get your answers quickly and correctly. Okay? So be aware of what you're doing when you approach these problems. The idea is to write out all of that work. Okay? Questions about that? You sure you don't have any questions? Because if I'm right, ta-da, come on, new slide. Quiz, yay. Okay, so what I'll go ahead and do is pass out some some slips of paper, just like last time. If you need to write more down, that's fine. Just grab another sheet of paper, either from me or just take some binder paper. To make this a little bit more interesting and potentially more helpful, go ahead and use your notes. So if you've been taking notes, that should help you out. If you haven't been taking notes, it's a little bit more difficult. And if your book does count as notes, I will accept that.
That works.
I will give you about 10 minutes to complete this, which is where I'm getting back to your question about how long the exams are. This is 13 questions. You will notice that 10 minutes is really not a lot of time, particularly that's aiming at less than a minute per question to actually get your answer. We just spent the last roughly hour. We spent the last hour solving one problem. Okay? So realize you will probably not finish this. The idea is to test your time resolve as far as approaching the problems. Answer the questions you can as efficiently as possible with your time. Do what you can with the rest of it. So yeah, 10 minutes. We're down to 55, right?
Yeah.
If you have questions, feel free to ask questions to me. And just to be more obnoxious, I'll keep talking. If you have a cell phone and you want to punch in calculations into the cell phone, that's fine if you didn't bring a calculator. For quizzes, you can use whatever you want to go through and run calculations. For the test, you have to have a calculator. But I'm not going to grade your answer. I'm grading the work.